Hey everyone, and welcome to The Explainer. Today, we're diving into something that's, frankly, a huge deal for anyone using Azure DevOps, permissions. We're going to talk about how to get away from those risky defaults and build a security model that's not just secure, but also actually works for your team. All right, let's jump right in.
Okay, so let's kick things off with a pretty fundamental truth, and this one might actually catch you off guard. Right out of the box, Azure DevOps is designed to be super easy to get started with, but that ease often comes at the price of security. And that, right there, is why having a real permission strategy isn't just a nice to have. Nope, it's absolutely non-negotiable. And that leads to a really important question you've got to ask yourself. If you've just thrown your whole team into that default contributors group, do you really know what they can do? Like, what's the full extent of their power in your project? I'm willing to bet the answer is way more than you think. All right, so first up, let's talk about the danger of those defaults. We're going to peel back the curtain on that standard contributor role and see what's really going on.
So just take a look at what a contributor can do by default. They can mess with your build pipelines. Yeah, think about the security risks there. They can delete entire branches. Poof, work is just gone. They can even change your work item types, which can totally mess up your project's whole structure. I mean, that is a massive amount of trust you're putting in every single person, and it makes it way too easy for someone to make a mistake or worse. So, how do we fix this mess? Well, to get there, we first need to get our heads around the three core concepts of Azure DevOps security. First up, access levels. This is like the top level gatekeeper. The way I like to think about it is it's your ticket to the theme park. It doesn't say which rides you can go on, but it determines if you can even get into the park in the first place, or maybe just a specific section. For example, a stakeholder might only get to see the front gate and the gift shop, while someone with basic access gets to explore the whole park. Next up, we've got security groups. Now, this is the absolute foundation of a sane, manageable security plan. Look, you never, ever want to assign permissions to individual people. It's a nightmare. Instead, you create groups based on roles, your developers, your team leads, whatever. That way, you're managing the role, not the person. It's so much easier to scale. And last but not least, we have the permissions themselves. So if access levels got you into the park and security groups put you with your friends, permissions are the rules for each individual ride. Can you operate the roller coaster? Can you just stand in line? Are you allowed to, delete the ride? This is where you get really specific and control who can do what. Okay, now here's a crucial rule you have to burn into your brain. When you're setting permissions, you've got two main options, allow and deny. And the one unbreakable rule is, deny always wins. Seriously, if someone is in 10 different groups that all allow them to do something, but just one group says deny, they're blocked. Game over. It's a super powerful tool, but man, you have to be careful with it. Okay, so now that we've got the basic concepts down, let's actually start building a solid security model. And we're going to do it using the principle of least privilege. All right, step one, and this is the big one. It's the most important, absolutely non-negotiable first step. You have to connect your Azure DevOps organization to Microsoft Entra ID. This isn't just my opinion. Microsoft themselves say this is the foundation. It centralizes everything. When someone joins your company or when they leave, you make the change in one place, Entra ID, and their access to everything, including DevOps, is automatically taken care of. It's a game changer. And the process is actually pretty straightforward. It's really just a four-step flow. First, you make that connection to Entra ID. Then, you create your role-based groups right inside Entra ID. Next, you sync those groups over to your Azure DevOps teams. And finally, you assign the actual permissions to those synced groups inside DevOps. Boom. You've got a system that's predictable, scalable, and way more automated. So, what does this look like in the real world? Well, here's a pretty good template to start with. Notice how everyone gets just what they need and nothing more. Your developers, they get basic access so they can create branches, approve PRs, and queue builds, their day-to-day job. Team leads get that plus a little extra, like managing branch policies. And the project admins, that group should be tiny, super small, and trusted. This right here is the principle of least privilege in action. All right, let's do a quick rapid-fire round of some practical do's and don'ts. Think of these as the golden rules that are going to keep your security model clean, effective, and, maybe most importantly, easy to debug when something inevitably goes wrong. Okay, first, the do's. Number one, and we've said it before, use Microsoft Entra ID groups for everything. Always.
Keep that project administrators group as small as humanly possible. Always grant the absolute minimum access someone needs to do their job. And please, please regularly audit who has access to what to stop that permission creep. Oh, and write it down. Document your model so the next person knows why you set it up this way. And now for the don'ts. These are the traps you really want to avoid. The biggest one, don't assign permissions directly to a user. Just don't. It will become a tangled mess, I promise. Also, try not to add users to a bunch of different groups with conflicting permissions. And whatever you do, leave the default project valid users group alone. Changing it can break things in weird ways. And finally, go easy on using deny permissions. Remember, deny wins, which sounds great until you're trying to figure out why someone can't do their job and you can't find the source with the block. Okay, we've covered the theory and the best practices. Now, let's get practical. How does this apply to the tools your team uses every single day? I'm talking about repos, pipelines, and boards. For your source code repositories, your number one weapon is branch policies. This is your guardrail. This is how you stop people from pushing code directly to your main or release branches. You can make pull requests mandatory, require code reviews from certain people, and basically ensure that every single change gets a second pair of eyes before it goes out. Now, for your pipelines, what are the crown jewels here? It's your service connections and your agent pools. These are the keys to the kingdom. They're what let your pipeline talk to your production environments. You have to lock these down. You need to be super strict about who can use them in a pipeline, and even more importantly, who has the admin rights to change them. And hey, don't sleep on Azure boards. It might not feel as high stakes as your production pipeline, but trust me, when someone accidentally deletes an entire epic's worth of user stories, it's chaos. You absolutely want to restrict those delete and permanently delete permissions. Give those powers only to team leads or admins to save yourself a massive headache. This quote really sums up the whole philosophy perfectly. It is always, always easier to grant someone more access later than it is to take away access after there's been a security incident. Start with the absolute minimum they need. If they need more, great, they can ask for it. But trying to claw back permissions that people are already used to having, that's a battle you don't want to fight, especially not after something's gone wrong. So here's my challenge to you. Go take a hard look at your own Azure DevOps setup and ask yourself this question. Is your permission model actually enabling your teams to work securely and effectively? Or is it a ticking time bomb, just waiting to go off because it's built on those risky defaults? The choice and the responsibility is all yours. Thanks for tuning in.